Welcome back to CIOs and Bow Ties. This is part 3, our final part with of our discussion with Liz Parrish, the CEO of BioViva. Very interesting discussion. I think it's a somewhat of a glimpse into the future as to how we will save our gene mapping data and how it will be used, and just a good insight into the future, I guess. Liz, I'd like your comments again. I'm the novice scientist, which is probably the most dangerous thing in the world. But everything that I see and read indicates to me that that sugar is actually quite an addictive substance. I don't know if you disagree with that, but sugar is actually quite dangerous for us in large quantities because of the buildup of insulin and the like. And so, again, just curious about your views on that, because you did mention, I think, type 2 diabetes, which, again, novice scientist, is a cause of too much insulin or insulin. I forget the term, but
insulin sensitivity.
Insulin, thank you, sensitivity. So please tell us a little bit about your views on that.
Sure. So number one, I'm going to preface with I'm not a dietitian, and I think that a lot of the information out there about diets are inaccurate. There are a lot of things that can make you lose weight, but they're not necessarily good for your cells. And then I will, or your longevity of your body, they can do some harm. The second thing I'll say is all of your cells need some sugar. You can, kind of with very few nutrients in sugar water, you can raise cells, and they're actually happy and healthy little cells. But I then will say, I will agree with you fully that too much sugar is a bad thing. And we know that it can drive inflammation and a myriad of problems. And actually, even people who have cancers who reduce the sugar down to just what's naturally found in foods tend to slow those cancers significantly. Alzheimer's can be slowed potentially significantly by taking extra sugar out of the diet. It is a driver of issues. It also builds up into glycation, which are misfolded proteins that we don't know how to remove from the system. It is not what you want. But then I will also tell you that I commiserate with everyone listening to this, because I'm a milk chocolate eater, and we are all addicted to sugar. Our cells do need some amount of sugar, but it is a highly addictive substance. And I know, because I travel all over the world, and when I go to countries that have less sugar in the food, I am literally left wanting no matter how much I eat. I am like jonesing for sugar, and I find myself going to the candy bar section. So yes, please eat less of that. So if you want to live long now, today, without doing gene therapy, you're not looking to bust anything significant, and you don't mind spending maybe a third of your life in chronic disease, because that's what we do today, but you want to maximize what you can get. It's really what you don't do. Don't smoke. Don't drink excessive alcohol. Don't drink it at all if you can help it. I mean, some people need blood thinners, and I think it benefits them that way, but there are other ways to do that. And don't eat excessive amounts of sugar, and you'll probably live at least to the maximum of your family's lifespan. Other than that, add as really fresh vegetables and fruits whenever you can, and add exercise.
Okay. Oh, that's sage advice. You touched on Alzheimer's a few times, and I'm curious about how you see gene therapy affecting Alzheimer's, how you would treat Alzheimer's. But then just generally, again, I think it was Dr. Aubrey de Grey came up with the term longevity escape valve inflection, something like that, basically inferring that the technology is actually moving rapidly enough that if you could survive for X amount of years, you could probably, your life span will be made even longer as a result. So, what are you seeing as far as longevity is concerned? So a comment about Alzheimer's and a comment about, how long we can ultimately seek to survive.
Right. So when we're looking at Alzheimer's, our first compounding treatment against it is actually twofold. It's two different delivery methods for telomerase. One that targets the neurons, one that targets the microglia, because the microglia are sort of, they outnumber the neurons by 50 to 1, and they're the cleaning crew of the brain. And when they get old, they don't do a very good job. So we're trying to make them young. And then we've got a compounding therapy with clotho to buffer it, because it was found that in the brains of people who even had Alzheimer's, they didn't have the subsequent cognitive decline if they had a natural upregulation of clotho. And so we know that, you know, cognitive ability with clotho is going to be super beneficial to people who have Alzheimer's. Now, we're still at the preliminary areas. I mean, I don't think there's any company on the planet who's moved as quickly as we have to get into humans, to get evidence in humans whether the therapeutics work. And then if you're not a candidate for medical tourism, let's say you just don't like it, or you can't afford it, or, you know, you don't travel for whatever reason, and you're waiting for a drug to come through the regulatory system, you know, the future really is finding out whether these things work in platforms like ours and humans first, and then it's going to be 8 to 15 years before we get a drug through the regulatory system. So you got to add that sort of time onto even a breakthrough discovery that shows massive eminent help. There is the gene therapy for congenital blindness showed benefit in every human from phase 1 all the way through phase 3 in low or large doses. And it still took many, many, many years to get to humans through a regular regulatory source. So Aubrey is talking about longevity escape velocity, at which point we, you know, we hit the ground running, and we do have all of this evidence. We have all this built-in evidence of being able to make cells young, behave young, not accumulate the damage. You know, the future human doesn't look like a 25-year-old. They don't look like an 18-year-old. There's no way to pin it, because we are going to create the future human that has never been seen before. Even when you're in an embryonic state, you can start to accumulate damage. When you're born, you're accumulating damage. We think of development, you know, from 0 to 20 or 21 as being a time when we're not accumulating damage, but in fact we are. And in some cases you can even find atherosclerotic plaques that lead to heart disease, to make that clear, in people as young as their 20s. There are accelerated aging diseases like progeria that are, the hallmark is short telomeres in children. They can die in their teen years of the aging diseases that we die of. They tend to look very old at that age. You know, we are accumulating damage from the point of conception. And so we have to create a body. So what is aging? Aging is degeneration over time. So what we need to do is upregulate regeneration in the cells to meet or beat that degeneration. And when we can do that, right now you're going to see changes in, you know, 1 to 2 years in epigenetics. So the DNA methylation kit that we're selling is what people use to find out if therapeutics are working, if they're actually changing the age, biological age in the patient. And so you're going to start to see, oh yeah, we think we've gained 1 or 2 years, but it might not be in the whole organism, and it might not be substantial enough to make that organism live 50 extra years, but it is a marked result. So we're already starting to see those things in trials, and that's fantastic. But when we really hit the escape velocity running, that's when we have showed marked results in upregulating regeneration over degeneration, and the biomarkers show it. So the biomarkers might, like blood markers and things like that, and metabolic markers might look similar to someone in their 20-something, but your biology, when we meet what we're trying to do over the next many years, will be something that we haven't seen in a human organism before.
Excellent. So you were quite prescient, because you did somewhat address my last question, but I'd like you to go a little bit deeper, if you wouldn't mind. Talking about designer genes, designer lifestyle, you mentioned somewhere, I think I heard you say something around, you know, you design where you want to live. And I thought that was curious from a biological perspective?
Oh, I want everyone to get really excited now. Usually at the end of the podcast, you're kind of, you're whittling out and you're like, oh
What
my
the heck
God.
was that?
Yeah,
Okay.
we did all the hard work first. Now I'm going to bring you to the beautiful
Yes.
future.
What does the future human look like? You try to bring it up earlier.
Right. This is the beauty of the technology. So right now we're just looking at genes that have a regenerative effect against biological aging and in childhood disease. They just go hand in hand. But in the future, we will be able to design the future in a much different way. So number one, what do you need in biology in order to move forward? You need a proof of concept. And we have proof of concepts all around us. We have trees that live to be 5,000 years old. We have, organisms that don't appear to age and die of the diseases that we die of. We have everything in between. We have really large creatures that live longer than us, and we've got really small creatures that don't live very long at all, and vice versa, very large creatures that don't live very long at all, and small ones that do. So that is what's called a proof of concept. That's something you don't have to take in the lab. It works. So in biology, they've taken the genes from some of these organisms like tardigrades. You may have heard about them. They're called water bears, little microscopic organisms that are resistant to radiation and freezing and things like that. And they've taken a gene from them. It's called damage suppressor, and put it in human cells. And guess what? The cells become radiation resistant. They become amazing. So, and in 2016, the genes from light sensing algae were put into human eyes to see if they could cure blindness. So we not only have a slew of human known genes that can upregulate regeneration. So how do we know telomerase works? Telomerase is turned on in your germline cells. It makes sure that you don't have children that are old immediately. It makes sure the telomeres are long in those cells. So we know in certain human cells, it kind of creates like an immortalized, healthy cell. So there are human genes that we're working with today that we're just upregulating the benefits from. But tomorrow, there are a myriad of other species cells. So genes are made up of all the same ingredients, A, T, C, and G. We have all the same ingredients. It's like, okay, think of it as a Mexican food restaurant, and you've got your refried beans, your tortillas, your lettuce, and your tomato.
100 different kinds of meals.
Oh, you can make 100 different kind of meals. Yeah, right. So it's just code, and there's a beneficial code in all of these different organisms that might give us a benefit. And then you might say, well, now you're slurring the line between enhancement and preventative medicine. And that's what it all does. So your antibiotics, every time you get antibiotics, you should have to sign off, I am getting an enhancing medicine that will unreasonably extend my lifespan compared to my ancestors. We already live more than 2 times longer than our ancestors did, and it's because of science. We take antibiotics, immunizations, we have workplace safety, and we wash our hands, one of the most basic ways to stay alive. And that is all life extending technology. Now this goes into another realm that it's exactly what that technology used to look like. Most of us would be dead. Only about 10% or less of the population lived to old age. The only thing that we haven't done is we haven't broken how far the oldest person can live. The oldest person today probably lives as long as the oldest person of yesteryear did live. And that's what we can do with this type of technology, because if we can create healthy cells, which we can do already, but if we can create a healthy organism, then if you're healthy, what do you die of? So then you start to die of accidents and things like that. But it goes farther than that. Now we can start looking at other organisms. We can start looking at other genes in order to make it so that you feel completely unlimited. And I'm talking you, the person who's listening to this, you, not me. I have my own pick of genes, and I'm excited about those, and I will continue to choose those, but you'll be choosing your own genes. So number one, you'll probably choose for a long life, because what's the point in dying if you're healthy? And we do choose to live generally, unless we have a terrible mental illness and we suffer from depression, which is a very sad thing, and we hope to address that with genetics. But then, do you want to colonize Mars? Do you want to live and do asteroid mining? Do you want to live in a polar region where there's not very much light?
Underwater?
And we will be able to modify you for that.
Potentially, you could live underwater. You could have gills.
So the changing of an organism substantially like that may be very difficult. Will we be able to find biology that make cells pick up oxygen in water and cover, make it so they're integrated into your skin? And would
Hmm.
that be enough? That's possible. I mean, really, maybe anything's possible. Phenotypical changes are a little bit more difficult, but we're already showing we can do that with muscle mass. It is quite possible. I would never put a limit on the technology. Maybe people can go between being men and women. I have no idea, but there may be
I
some
shouldn't laugh,
sort of.
yeah.
I imagine there would be some sort of, like, if you wanted to make super changes like that, you may need to be put into like almost an incubator for a matter of months so that you can have a biological change.
Hmm.
But that would be technology of the future. This would be more simplistic technology right now, like radiation resistance,
Right.
increasing your muscle mass if you want to climb mountains, increasing, maybe upregulating and turning back on the vitamin C gene if you want to live somewhere where you don't have access to that type of technology that used to be made by our bodies. We have genes that can make that. So upregulating a slew of cells that can create nutrition at the level that we need it when it's not in abundance, creating strength where we need it, faster, stronger, smarter, better humans.
Wow. Well, that's very exciting. I'm out of breath actually. Um, I think the sky's the limit. It's up to your creativity. So, folks, I think we're going to leave it there. I'm going to let your brains continue spinning around as to the possibilities. Liz, I really appreciate your time today, that you came out, you were willing to speak to our podcast listeners and explain a little bit of the science to some of us novices. I know that you are in a fundraising mode. So why don't I just hand it over to you for the final comments, talk a little bit about your fundraising, and thank you to your Great Dane, who was actually very silent during the interview.
Yeah, yeah, he was lovely, and the cat was quiet too. I thought it was going to come and scratch down the door. So what we are a privately held company, and we choose to be a privately held company. We're not looking for an IPO, but we are interested in spinning out our research and development into a traditional funding source. It's looking for about $5 million in order to continue its approach to patenting. It's an incredible platform because it's using a gene therapy delivery method that is just as helpful as the most common one that we're using today, but it can deliver multiple genes. And that is really the future of the technology. And then bioinformatics, we're interested in also spinning it out for a similar amount into a regular, traditionally funded company that can potentially eventually go IPO. But BioViva USA Inc. will continue to be a privately held company because of some of the sensitive work that it does and the immense value that it can give humanity by existing and being funded by sources who believe in what we do. And it will always have ownership over the other companies. And then, integrative health system is not a
Hmm.
fundable endeavor. It is an offshore company that is exclusively tied into BioViva, the holding company.
Got it. Great. Thank you very much. Have a wonderful day, and we appreciate you coming on board.
Thanks for having me, Greg.